Welcome back. We're continuing to look at linear relations and functions. In this video, we are going to be looking at linear relations and linear equations, and we're going to talk about standard form. Standard form of a linear relation is when it is written in the form ax plus by is equal to c, where a is going to be a whole number. So if we remember back, whole numbers are going to be 0, 1, 2, 3, 4. So 0 and the positive counting numbers. And b is an integer, and so an integer can be positive or negative, but those are the numbers that don't have a decimal following them. So negative 10, positive 3, 17, 0. All of those are going to be integers. A or B may be 0, but A and B cannot be 0. Many times when we see this particular equation, we often see this as with C also being an integer, but it's not necessary. Sometimes C will not be an integer. A and B must be integers, with A being positive or 0. So if I take this to be my standard form of a linear equation, I can rewrite some linear equations which represent linear relationships in standard form. So if I start with this equation, negative 3/10 x equals 8y minus 15. My first step when rewriting in standard form is to collect x's and y's on one side. So I'm going to subtract 8y from each side to get everything to get my x's and y's onto the left and my constants onto the right. So this becomes negative 3/10 x minus 8y is equal to negative 15. So I have my x's and y's on the left, which is what's necessary in standard form, but a is not a whole number. A is both negative and not an integer. It's a rational number, but it's not an integer. To make negative 3/10 into an integer, I need to multiply both sides of my equation by 10. So that will give me, if I distribute the 10 into the left-hand side, the 10 will cancel with the negative 3/10, giving me negative 3x. 10 distributed into negative 8y will give me negative 80y is equal to negative 150. Whole numbers are positive, so I need to multiply through by negative 1. Distributing that into each term will give me 3x plus 80y is equal to 150. So A is equal to 3, B is equal to 80, and C is equal to 150. In my next problem, 3x minus 6y minus 9 is equal to 0. I want to first start by getting my x's and y's on one side and my constant on the other. So I'll add 9, and I get 3x minus 6y is equal to 9. You might look at this and say 3 is a whole number, 6 is an integer, I'm done. But if I look at all three of these values, they all have a common multiple. If I divide both sides of my equation by 3, I end up getting x minus 2y equals 3. They're all still integers. So I'm going to try to reduce this by dividing by common multiples. So this is my standard form of the equation, giving me a is equal to 1, b is equal to negative 2, and c is equal to 3.